Everyone, this is another video on electromagnetic theory where we'll be discussing some important points and concepts, right? So, today we'll be discussing polarization, right? So, we're discussing polarization, okay? So, important points are transverse wave. Transverse wave can be polarized, okay? But longitudinal wave cannot be polarized, okay? Longitudinal wave cannot be polarized, right? Transverse wave means EM waves. Okay. So another formula: intensity is directly proportional to amplitude square. Okay. So suppose amplitude square is equal to a square is equal to a1 square plus a2 square is 2 a1 a2 cos phi. Then I is equal to I1 plus I2 plus 2 root I1 I2 cos phi. Okay. Because I is directly proportional to a square. So like I root I is directly proportional to a. So in place of like a square, that means root I square, that means a1 square root I1 square I1. Okay, but a1 is root I1, a2 is root I2, right? So this is important formula for intensity. Okay, now from here we can also write I max is equal to what, root I1 plus root I2 whole square, whereas I mean is equal to root I1 minus root I2 whole square. Okay, root I1 plus root I2 whole square. I mean is root I1 minus root I2 whole square. Now then, now, okay. So we will write the polarization things. Okay. So if suppose two waves are there, if the angle phase difference phi is equal to 0, pi, 2 pi, and all, then it will be plane polarized. Okay. But if phi is equal to in order of pi by 2, 3 pi by 2, and all, okay, then we have to do what? We have to check amplitude, and according to that we will divide it, check amplitude. So suppose amplitude of one wave is equal to amplitude of the other. E0 1 means amplitude E0 is amplitude 1 means first wave is equal to amplitude of wave, then it's called circularly polarized. Circularly polarized. Okay. If amplitude of 1 is not equal to amplitude of 2, then it is called elliptically polarized. Elliptically polarized. Okay. Yeah. Right. Also, if phi is other than anything other than 0, pi by 2, 3 pi by 2, and all, then also it's elliptical polarized. Really? Right? This is the thing. This is what we remember. If 0 pi 2 pi plane polarized, if pi by 2 3 pi by 2, then we have to check amplitude. If both the amplitude are same, this is circularly polarized. If this is not same, then it is elliptically polarized. If the phase difference is other than 0 pi by 2 3 pi by 2, it is elliptically polarized. Okay. So the general equation of electric field will be E is equal to E naught Like it will be in this form: x cap plus e to the power I phi y cap into e to the power I kz minus omega t. This is your electric field. Okay, so this is your electric field. Okay, next. So we will move to question. Solving question will help. Yeah, first question: electric field of an electromagnetic wave is E is equal to how much is given? E is equal to given E naught cos kz plus omega t I cap plus 2 E naught sin kz plus omega t j cap. Another thing, if it is kx plus minus, it should be kx minus omega t always. If this one is minus, then it is in the positive x direction. If this one is plus, this is in negative x direction. So E is equal to E naught cos kz plus omega t I cap plus 2 E naught sin kz plus omega t j cap. Right. So can you tell me, I can, what is the phase difference? First of all, I can write this as also, tell me, kz plus omega t I cap plus 2 E naught cos kj plus omega t plus pi by 2 also, isn't it? Right? Or this one you can write as sine, right? Sine kj plus omega t plus pi by 2. Anyway, even not that, even you can see this is I cap, this is j cap. So what is the phase difference? This is your x axis, this is the y axis. So the phase difference pi by 2 already. So pi is equal to pi by 2. Forget this one. From the direction only we can, but anyway. So phi is equal to pi by 2. Phi is equal to pi by 2. So if phi is equal to pi by 2, we have to then check what? Amplitude. We have to check amplitude. See, this is E naught, this is 2 E naught. So amplitude is not same. So if amplitude is not same, it will be what? Elliptically polarized. So the answer is what? Elliptically polarized. But in which direction? See, it is kz plus omega t. Kz plus omega t. If this one is in the middle, it's a plus, then the whole wave will be going in the negative z direction. Okay. So elliptically polarized in the negative z direction. That will be your option C. Okay, that will be the answer. Okay. Yeah. Next question: find the polarization of E is equal to E naught x cap plus y cap e to the power I kz minus omega t. Okay. So what? So see, we have written the previous in the previous slide. What is the general formula of electromagnetic field? This is E naught x cap plus e to the power I phi y cap into this one. So let me write this. Let me write the general formula, general equation. Electric field is E naught x cap plus e to the power I phi y cap e to the power I kz minus omega t. Okay. So see here, if we compare, this is x cap, this is y cap, this is e to the power I phi y cap. That means e to the power I phi is how much? 1, isn't it? E to the power I phi is 1. That means e to the power I phi is equal to e to the power 0. So I phi is equal to 0. If I phi is 0, phi is equal to how much? 0. So phase difference is 0. If phase difference is 0, then it is what? Which polarization? Linear polarization or plane polarized? Linearly polarized or plane polarized or linearly polarized. Okay, simple. We just try to compare it with the original equation of electric field. Okay, electric wave vector, electric field wave. Sorry. So this is it. This is the question number two. Next question. Question number three. So E1 is given. First electric field E0 sine kz minus omega t minus pi by 3. Sorry, plus pi by 3 I cap. Your E2 is given E naught sine kz minus omega t minus pi by 6 j cap. Okay, j cap. First of all, we can see this is I cap, this is j cap. That means it's in the x direction, it's in the y direction. So the phase difference is pi by 2. That means they're what? Circularly polarized. Okay, circularly polarized. Alright, that's it. And also, if the like, no, this is not right. Like, first of all, phase difference is pi by 2. Then we have to check what? Amplitude also. So we after checking amplitude, then only we can conclude this is circularly polarized. Okay. If the amplitude is same, circularly polarized. If amplitude is not same, then what? Elliptically polarized, isn't it? Yeah, that's the answer. That means circularly polarized. Next question, question number four. Question number four. Find the polarization whether it is right or left. Okay, there is a thing called right circular polarization, right circularly polarized, or left circularly polarized. Okay, RCP or LCP. So how to do this? See, first of all, what will you do? We'll put z is equal to 0. Okay, if z is equal to 0, see, if I put z is equal to 0 in both the equation, e1 is equal to e naught sine omega t I cap, e2 is equal to e naught cos. This is cosine. Okay, that means cos. Here in the question, it's cos omega t j cap. All right, omega t j cap. So now put what? Let's put omega t is equal to 0 now. So if omega t put 0, then this one will become half. What? E is 0. This one will become E naught j cap. Okay. Now put omega t is pi by 2. If put omega t pi by 2, E1 will be E naught I cap, but your E2 will be what? 0. You get it? Got it? Yeah. So my value is going from what? So my value is going from, can you tell me? It's going from j cap to I cap. For example, this is the x axis, this is the y axis. So this value is E naught j cap, E naught I cap. So first omega t is 0, then omega t pi by 2. This is 0 pi by 2. Right? Like this is going from this to this. E naught j cap to E naught I cap. That means this is going in the what? Right. So this is your right circularly polarized. Okay. Okay. First 0, then pi by 2. This is 0. Okay. Yeah. Okay. So this one is your polarization. Okay. Next what? Next is what? Just a second. Next is Brewster's law. Brewster's law and polarization of polarization by reflection. Polarization by reflection. Right? Polarization by reflection. So suppose this is a surface, okay, interface. This is a normal. This is your unpolarized incident light. Unpolarized incident light is incident here. Okay. So now this will be reflected as polarized. Okay. Polarized. This will be reflected as polarized light. Hmm. So this is your theta I. So theta R. But there will be some part also that will be transmitted. Okay. Transmitted. So this is your theta T. Okay. Theta T, and the angle between reflected and transmitted is 90 degree. Okay. This is N1, refractive index of first medium N1, N2, N1. And this is a what? This is transmitted and this is also polarized. This is a transmitted ray. But this one is what? Completely polarized. The one that is reflected. Completely polarized. The transmitted one is half polarized. Right? So theta r plus theta, like, see, this one is 90 degree. This whole thing is what? 180 degree. So theta r plus 90 plus theta t, I can write it as 180 degrees. So theta r plus theta t is equal to how much? 90 degree. Hmm? So theta r plus theta t is equal to 90 degree. So theta r is equal to 90 minus theta t. Alright. This theta r is called your what? This theta r is called your what? It's called theta b, Brewster's angle. Okay. This is called your what? Theta b is called your Brewster's angle. It's equal to what? It's equal to theta I is equal to theta b. R. Okay. So we can write what? Theta b is equal to 90. You can write pi by 2 minus theta t. Alright. Hmm. I can also write another formula for it, that is theta b is equal to tan inverse n2 by n1. Okay. This is an important formula where n2 refractive index of first, second one, like the interface, and this is the of the medium. Okay. So theta b is equal to tan inverse n2 by n1. Theta b is equal to pi by 2 minus theta t. This is the Brewster angle. Okay. It's a very important part. Questions also come from here. Okay. Let's do some questions then. Yeah, what is saying? Wait. Yeah. A beam of unpolarized. This is question number 5. Beam of unpolarized light in a medium with dielectric constant 7 1 in a reflected from a plane formed is another medium dielectric constant epsilon 2 is equal to 3 epsilon 1. The two media have identical magnetic permeability. Yeah, it doesn't matter. The angle of incidence theta 1, sorry, this is 60 degree angle of incidence. Then reflected light is it's saying plane polarized perpendicular to plane of incidence, plane polarized perpendicular plane of incidence parallel to the circular polarized has the same polarization as the incident light. Okay, so let's do it. This one. So your theta b is how much? How much is it? 60 degree here is equal to tan inverse is equal to tan inverse n2 by n1, isn't it? So n2 by n1 is how much? Tan 60, which is root 3. Okay, tan versus root 3. So we know what n2 by n1 is how much? Mu 2 epsilon 2 by mu 1 epsilon 1, isn't it? You know it, this one. Hmm? Right? Yeah. So this one is, see, mu 2 is equal to mu 1 is written here. Same relative permeability, identical magnetic permeability. So mu 2 is equal to mu 1. So what is that? Epsilon 2 by epsilon 1. Your epsilon 2 is what? 3 epsilon 1 by epsilon 1. That is root 3. Okay? Root 3. Alright, sorry. This one is theta I, no? Theta I. Okay, wait. I've solved it the wrong way. My bad. See how to do it. Anyway, the original version. Okay, this is wrong. Okay, I'll do it again. See, a beam of plane polarized light is reflected in a um, medium with dielectric constant epsilon 1 is reflected from a plane interface formed with another medium of dielectric, this one. So this reflected ray, this is your theta I. Okay, by mistake I took it as theta B. That's wrong. This is your theta I only, right? So if I draw it again, sorry, this is your incidence normal. This is your angle of incidence here, 60 degree. So theta I is equal to 60 degree, right? So what? Theta B is how much? Tan inverse n2 by n1. So we know n2 by n1 is mu 2 epsilon 2 by mu 1 epsilon 1. So this is your how much? N2 by n1 is mu 2 is equal to mu 1 is given in the question. Also given epsilon 2 is equal to 3 epsilon 1. Okay. So 3 epsilon 1 by epsilon 1, that is root 3. So n2 by n1 is equal to root 3, which is equal to what? Tan inverse. Sorry. Yeah, root 3. So theta b is how much? Tan inverse n2 by n1, that is tan inverse root 3, that is what? Pi by 3, 60 degree. Okay, that is pi by 3, 60 degree. So see, Brewster angle is 60 degree and the angle of incidence is also 60 degree. Okay, so if theta I and theta b are same, if write down in the next slide, no, there is no. You can write down if theta I is equal to theta b, then what? Reflected light is plane polarized. Okay? Plane polarized, and that is perpendicular to plane of incidence. Plane of incidence. Okay, it will be perpendicular to the plane of incidence. Okay, reflected light. Plane polarized, and perpendicular to plane of incidence. All right, perpendicular to plane of incidence. Okay, yeah, yeah. This was your one question from Brewster's law. Next, let me do some theory. Okay, next is your Malus law. Okay, Malus law. So what is Malus law? Malus law is like if theta is the angle between direction of electric field and polarization axis. Okay, theta is it's not visible. Angle between angle between what? Angle between direction of electric field, and polarization axis. Okay. And I naught is what? I naught is your intensity of light. Intensity of light, right? So intensity of transmitted ray is what? Intensity of transmitted IT is equal to I naught cos square theta. I naught cos square theta. A is equal to A naught cos theta. A square is equal to A naught square cos square. Like that. I naught IT what? IT is equal to the transmitted, it is incident like intensity of transmitted ray is equal to I naught cos square theta. Okay. Suppose this is your unpolarized light like this. Okay. It's going here. This is your polarizer. So this will be polarized like this. Okay. And this is another polarizer. Okay. This makes an angle theta degree with it. So it will come back again like this. This is called a analyzer. Okay. This is a polarizer. This is a analyzer. All right. Okay. So now we'll see uh, boundary conditions. It's very important in this topic. Boundary condition. First boundary condition is what? First boundary condition is E above parallel is equal to E below parallel. Okay. Second is D perpendicular above is equal to D perpendicular below. Okay. 3. Now B perpendicular above is equal to B below perpendicular, and H above parallel is equal to H below parallel. So for electric field parallel, magnetic this H is parallel continuous. D perpendicular and B perpendicular. This is the way to remember it. E parallel, H parallel, B perpendicular, D perpendicular. These are like continuous each other. Okay. Alright. Next is what? Next is Fresnel's equation. Fresnel's equation. Fresnel's equation. So what does it say? Reflection and refraction of reflection and refraction of EM wave EM wave at normal incidence of at normal incidence of dielectric interference. Okay, so this is the interface, light coming in, reflected, refracted. K, K dash, K double dash. This is the incident, reflected, and this is your refracted. Okay, so this is your permeability mu1, permittivity mu2, permeability mu2, epsilon 2. Okay, so the formulas are electric field divided by E naught is equal to how much? 2n1 by n1 plus n2. Now E naught dash by E naught double dash n2 minus n1 by 2 n1. So these two formulas we have to remember from this topic. E naught double dash by E naught is equal to 2n1 by n1 plus n2. E naught dash by E naught double dash is equal to n2 minus n1 by 2n1. So if I take the that one, E naught dash by E naught is equal to n2 minus n1 by n2 plus n1. Okay, n2 minus n1 by n2 plus n1. So okay, next this is another formula. Now reflect R is equal to what? Reflected intensity. R is equal to reflected intensity divided by incident intensity. Okay, so reflected intensity is what? E naught dash square divided by E naught square. So that implies this whole square, right? So n2 minus n1 by n2 plus n1 whole square. This is R. Here, yeah, this is R. Now, what is T? T is what? Refracted intensity. Refracted intensity divided by incident intensity. That is transmission. This is a transmission coefficient. The previous one was reflection coefficient. So this is your what? E naught double dash by E naught whole square. That means 2n, like if we right, T will be what? 4n1 into by n1 plus n2 whole square. This is a T. What is R? R is your R is your R is your n2 minus n1 whole square. Okay. So you can see R plus T should always be 1. Reflection coefficient plus transmission coefficient should be, remember this too. Right? Hmm? Yeah. Okay. Another point you can write: transmitted component of electric and magnetic field has no phase change. Alright? Yeah. Okay, let's go to questions. Yeah, this is a question here. See, circularly polarized light with intensity I naught is incident normally on a glass prism as shown in the figure. The index of refraction, like refractive index, is given 1.5. Intensity I of light emerging from the prism. Okay, so intensity I emerging from the prism is asked. Circularly polarized light with intensities light is coming with I naught, going with I 45, 45. Refractive index is 1.5. Okay, so here refraction or angular refraction is concerned. So R we know is what? N1 N2, N1 plus N2 whole square. P is what? 4 N1 N2, N1 plus N2 whole square. Okay, so what we asked, what can we do here? We can calculate T. 4 into, it's coming from AR, so N1 is 1, going to class 1.5 divided by 1 plus 1.5 whole square. So this is 6 divided by 2.5 whole square. So T is equal to 6 by 6.25. Right, that will be a 0.96. So I will be what? I will be 0.96 I know. Alright. Yeah. Hello. Hmm. Oh, that's done. Okay. So this is your answer. Next question. Try this question. Okay. Try this question. I'm just coming in 5 minutes. Try. So consider three polarizers P1, P2, and P3 placed along an axis as shown in the figure. Unpolarized light is going. Okay. So the first wave will be what? The one that is coming through here, like this I1. I1 will be I naught cos square theta, isn't it? Alright, and so there will be I naught into cos, but this is your 45 actually. Okay, so it will become I naught by 2. So I1. Now it will go again to this. Okay, so I2 will be what? I will take this as I naught cos square again, cos square theta, like, okay, this one, cos square theta into square 90 minus theta, right? So I naught by 2 square theta into sine square theta. So this is I naught by 2 into 4. If I multiply 4 here, it will happen I naught by 8 sine 2 theta whole square. And that's it actually. That's the answer. Okay. Yeah. The next question. An EMF is, I think, question number 8 or 7. 7, I think. An EMF is initially a water incident on a water-air interface. The phase of perpendicular component of electric field of the reflected wave into the water is found to remain the same for all angles of incidence. The phase of the magnetic field H. Incident water-air interface. This is water phase of the perpendicular component of electric field of the reflected wave into the water is found to remain the same for all angles of incidence. Phase of the magnetic. See, um, we have written those things. Right? E perpendicular, right, or E parallel. E parallel will be equal to E above, like, E below, and H parallel is equal to H below. But B D perpendicular is equal to D below. B perpendicular will be D B perpendicular. Okay. So the phase of magnetic field H. See, H will change. I think by pi by 2. Pi 1. Okay, water air interface. So here, water. Okay, water air. So that means first one is water, second one is air, isn't it? Yeah. This diagram is wrong. First one is water. Like it's going like this. So the light is going like this. Okay. So this one is N1. This one N2. So N1 is actually greater than N2 here because water refractive index is greater than air. Okay. So that will imply that what reflected component of perpendicular magnetic field has a phase change of pi. Okay. So if n1 is greater than n2, then what the phase change will be pi. Okay. Remember this. So the change by pi. That is the answer. Right. Yeah. Next question. This will be at number 8. A beam of light frequency omega is reflected from dielectric metal surface and normal incidence. The refractive index of dielectric medium is n, and the metal is n2 is equal to n1 is n2 is equal to n equal to 1 plus what is it? 1 plus I rho. Okay. If the beam is polarized parallel to the interface, then the phase change experienced by the light upon reflection. Phase change again asked here. Okay. So how can we do it? Let's do this. So ER, okay, is equal to E dash divided by EN. This is equal to N1 minus N2 by, we know N1 minus N2 by N1 plus N2, isn't it? So ER is equal to how much? N1 minus N2 by N1 plus N2 EI. Okay. So now we know, okay, let me write it again on the next slide. ER is equal to N1 minus N2 by N1 plus N2, sorry, EI. So N1 is N, N2 is how much? N2 is N equal to 1 plus I rho, isn't it? I rho. So if I put it here, N minus N equal to 1 plus I rho divided by N plus N equal to 1 plus I rho, isn't it? This one will become EI. This one here, EI. This is N minus N minus N I rho divided by N plus N I rho. E2. Sorry, EI. So this will be cancelled. This minus N I rho. If I take N common here, this will be N plus N2, right? 2 plus I rho. This will be minus I rho divided by 2 plus I rho. Hmm. 2 plus I rho. So I have to rationalize it. So what will I do? I will multiply 2 minus I rho on both numerator and denominator, not rationalize to make it real. So this one will become minus 2 I rho minus rho square divided by 4 plus rho square. Okay, 4 plus rho square EI. Hmm. Okay. Okay. So what can I do now? Phi, your phase angle is tan inverse. What is it? Coefficient of, remember this, imaginary part, coefficient of imaginary part divided by coefficient of real part. That is tan inverse. Imaginary part is your 2 rho divided by real part is rho square. This becomes tan inverse 2 by rho, which is the answer. This is a phi. Phi is equal to tan inverse 2 by rho. Okay, this is your phase angle. If you check the options, the option is A. So what did we do? ER is equal to N1 minus N2 divided by N1 plus N2 into EI, and we have N1 as N and N2 as given is N plus N equal to 1 plus I rho. We just put it or just kept rationalizing or like make it real, and at the end, like whatever we got, we have to find phi as tan inverse what, imaginary part and real part. Okay. Yeah. Okay. Next question. A plane wave, electromagnetic wave incident normally on the surface of a material is partially reflected. Incident on a surface of a material is partially reflected. Okay, that means something is transmitted also. Um, Measurements on the standing wave in the region in front of the interface show that the ratio of electrical amplitude at the maximum and minimum is 5. Ratio of reflected intensity to the incident intensity. Okay, so how will we do it? See, E max by E min is equal to what? E max by E min is E plus EOR by EOI minus EOR, right? Yeah, yeah. So E max by E min is equal to 5. 5 is equal to this much. Right again. EOI minus EOR. So if I take to the side 5 EOI is minus 5 EOR is equal to EOI plus EOR Alright. So if I take to that's it, 4 EOI is equal to 6 EOR, isn't it? Hmm. So EOR by EOI is equal to 4 by 6, that is 2 by 3. Hmm. What do I ask here? Ratio of reflected by incident intensity. So we have the reflected and incident amplitude. This is amplitude of reflected divided by amplitude of incidence is equal to 2 by 3. But intensity is what? Intensity is amplitude square. So amplitude max, sorry, intensity max by intensity mean is equal to amplitude max by amplitude mean square, isn't it? So amplitude max by amplitude mean, that is what? 2 by 3 whole square. That is 4 by 9. Is it right? Okay. So these are the method again. Same thing. Just these formulas you have to kind of remember. Hmm? Yeah. So yeah, this was question number 9. I think we did 9 questions and some theory from like polarization, Brewster's angle. I hope. Yeah. This is it. Thank you for watching, and we'll see more to do more questions in the next sessions. Okay, thank you.